Back to Algebra with Miss Swartz. Today we're continuing with equations, but our equations will look a little different today as we will be looking at literal equations. So we're first going to talk about what is a literal equation. So let's get started. A literal equation is an equation that has two or more variables. So I'm going to give you an example here. X plus y equals 10. That would be a literal equation. And you may be thinking, well, how do I solve a literal equation then? Well, you're going to be told which variable they want you to solve for, okay? So we may be asking you to solve for x in this case. We may be asking you to solve for y. It just depends on what they want. From there, to solve it, we just have to get the variable you are solving for alone. So we can use the same principles we use when solving regular equations. So we're using those inverse operations. There isn't a lot different here. Instead of numbers, though, we will see letters. And that's where people start to get confused. Try to remember, a variable is just like a number. We can treat it just like a number because it's just a number we don't know yet. So we can act like it's a number. So let's do some examples. This first one, we have 3y plus 4x equals 9. And it tells us we want to solve the literal equation for y. So I'm trying to get y alone because that's my goal in solving an equation. Remember, get your variable alone. And I'm solving for y, so I'm trying to get it alone. I have this 4x here, and I can treat it just like if I was just adding 4 and not 4x. So if I subtract 4x from this side, I would have to do it to this side as well. So now what I'm left with on this side is 3y equals, and over here I can just write what I have, 9 minus 4x. Remember, I can't combine these like I would normally be able to because they're not like terms. From here, I'm still working to get y alone, so just like I would do on a normal equation, I'm going to divide by 3. I'm dividing that whole side by 3 there. So y is going to equal 9 minus 4x over 3. This would be my answer to my literal equation. I now have y alone, and everything over here, I'm just working with what's shown to me. Now, we have to make sure simplification happens if it can, but in this case, we can leave it like this. Okay, so let's try another example. We have this literal equation here. We have 20 equals 8x plus 4y. And again, it says solve for y. So I'm going to treat my 8x like it's just a number. I'm going to subtract 8x from both sides. So I have 20 minus 8x equals 4y. And now, just like I would a normal equation, I'm going to divide by 4 so I can get y by itself. So I have 20 minus 8x over 4. Well, I can simplify this. 20, if I break it into parts, 20 divided by 4 is 5, and 8 divided by 4 is 2, so y is equal to 5 minus 2x. We want to make sure it's as simplified as possible. Okay. All right, so now we have 3 variables involved. And it wants us to solve for x in this case. We have a x, a y, and a z. So we're working to get x alone. Okay. Right now, we have y equals 3x plus 5xz. Don't think that you can combine this 3x and 5x because this is a different term when we have z with it. So the first thing we'll do is we're going to subtract 3x from both sides because we need to get rid of that. We can treat it just like a number, so we'll subtract it from that side. So we have y minus 3x. Okay, but then you might notice the problem that we're going to run into here. X is now on both sides. So that doesn't work, what we just tried to do, because that was kind of our pattern. We would always subtract first or add first. So we have to back up and think about this a little bit. I'm going to erase what we had. Okay. So if I want to work with this x, I have to notice that my x is involved in both of these pieces. So I kind of have to rewrite my problem here. What I'm going to do is I'm going to pull my x out in front. And you can think about it like the distributive property in reverse. If I pull my x out in front, if I take 3x divided by x, I have 3 left. And 5x times z divided by x, I have 5z left. So I pulled that x out in front. Now I'm kind of working with something where I'm not going to have x's on both sides. So now if I want to get x alone, this makes this really easy. I'm just going to divide by what's inside the parentheses here, 3 plus 5z, because then those will cancel. If I do it to one side, I have to do it to the other. So y over 3 plus 5z is going to be equal to x. So all by itself. So notice why this works, because if I were to distribute this in, I would get what I have up here. So when you have a variable that is the same in two parts of your equation, you can pull it out and rewrite the equation so that you'll be able to easily solve for whichever variable they ask you to solve for. So I know that one was a little bit different. Hopefully you can kind of understand that. If you have questions, feel free to ask. All right, I want you to try these two on your own. Once you are done with those, you can always come check with me. If you don't quite get the video done in class, always a reminder, it's good to finish the video. Your homework is actually going to be in your textbook today. Let's see. Page 44 through 24 even will be your homework assignment. So you can get started on that once you finish the video. Have a great day.